Juristisch geçiyorum. Okay. So we'll switch in English. So hi everybody. Hi here at the live place and also on Zoom. Welcome to this workshop. We'll talk about scaling Ethereum, a deep dive into the L2 landscape. And hopefully by the end of this presentation, you'll have more insights of what's happening on L2, but also in the world of Starknet. I'm also excited to be here. So thank you for the invitation. Thank you for having me here. And yeah, let's get this started. So initially I have a presentation prepared. So let me just scroll back to the start. So as I mentioned, I'll be talking about the L2 landscape. And then I'll take a deep dive into the differences and nuances between the rollups. And finally, we'll take a look at Starknet specifically. So for those who do not know me, my name is Robert Kodra. I'm a developer advocate at the Starknet Foundation. Let me just get rid of this. So I'm a developer advocate at the Starknet Foundation. I've been working there for roughly 1 and 2 months, maybe. It's been quite a journey. I'm meeting a lot of developers, onboarding them to the Web3, and so far it's been quite a good experience. In terms of languages, I know English, Romanian, and Hungarian. I also know German, but it's a bit rusty, so I haven't added that there. And if you want to reach out to me, I have my Twitter, Telegram. Feel free to connect with me, DM me. And if you have any questions about Web3 or Starknet or anything in general, feel free to reach out. Okay. Good. So the agenda for today, as I mentioned, we'll initially take a look a little bit about Ethereum's history. So we're going to check a little bit about like the most important things in terms of like L2 importance as well. Then we'll take a deep dive into L2 landscape. We'll talk about why Starknet, and finally, I'll leave you with some information on how to kind of like get started with Starknet. Okay, so let's check Ethereum's history. So I put here a timeline, and as you may know, Ethereum started around 2015. Vitalik and other co-founders created Ethereum in 2014, and I think officially they launched somewhere in summer in 2015. Vitalik has been a true OG in this space, and there's I think he's coming from the BTC community. He was writing like newspapers and things like this, and then he decided that we need a better blockchain that we're able to write smart contracts, and this is why Ethereum was launched. Together with Solidity, which is a smart contract language, you're able to create these smart contracts that is on blockchain. Ethereum is quite powerful. It's decentralized, it's secure. We've been seeing Ethereum since 2015, and it's very, very powerful. Next up, in terms of like 2017 and 2018, there was a project called CryptoKitties. So I'm curious if anyone knows about CryptoKitties. Right. That's good. That's good. So initially, CryptoKitties was, I think it's the first NFT gaming project. And first, when they launched, they had a massive influx of users and players, and basically just brought up the like network congestion, right? And that's when like Ethereum noticed that, hey, this is currently at this stage that the network is not scalable. And what I say network congestion is that I think transaction fees were several, I don't know, like $40, $50, I don't even more. So it was quite expensive to create a transaction and play the game. And in today's society, like if you want to play something and to pay like $40 for a transaction is insane. So it's quite high. So it kind of like brought to the attention that there's work to be done in terms of scaling and making it more efficient. And what happened next is in 2019 and 2020, there were kind of like experimental projects or that came. And I call this the rise of rollups because that's when the majority of these rollups such as Starknet, Arbitrum, Optimism, and ZK Sync started developing these rollups. Yeah, they meant to try to scale Ethereum and have a higher throughput. In 2022, as you may know, the merge happened. So Ethereum switched from proof of work to proof of stake. It was a difficult process, a very difficult process because there were so many things to take care of. And the developers and engineers of Ethereum and also like the community managed to do this. It's quite a complex work, and they successfully managed to switch from proof of work to proof of stake. And this basically changed Ethereum per se. At one point it was deflationary. I think I've checked today, and currently it's like 0.3% inflationary. But yeah, it reduced from, like, if it would be with proof of work, I think it would be somewhere around 3.8% of being inflationary compared to 0.3. Next up, in 2022 and 2023, we see some breakthroughs for layer twos and some maturation or maturity. We see that most of the L2s are being launched. So we have ZK Sync, Starknet being launched, Optimism, I believe they already launched with 1 year prior. But what's interesting is that we noticed that there's significant growth in TVL, total value locked, and also users. So this is kind of like the L2s start to take effectiveness overall the network. Just for the public, all the L2s, majority of the L2s are built on top of Ethereum. We do share the same goal. We are trying to help Ethereum, scale Ethereum, and offer users cheap fees and more features. We will talk about those in just a sec. And finally, I think one important history or like important upgrade for L2s in general for rollups is the EIP 4844, also called proto-dank sharding, which basically introduced the blob data for rollups, and it made it more cheaper for rollups to have the data on Ethereum. Okay. I never mentioned regarding questions. Feel free to interrupt me at any point if you have any questions, and we'll be able to take them. So whenever you have something, feel free to ask me. Okay, going next, we have the rise of layer twos. So initially, as I mentioned, in 2019, they started as experimental projects. It was very difficult to build these layer twos, mostly because, well, some of them, because some of them are EVM equivalent, and it's easier to develop, but then some of them are EVM compatible, which there's some nuances and differences, and it's more difficult to develop on them. Today, layer twos, they have reached key decentralization milestones. So we noticed that I think last year and this year, all the layer twos are focusing on decentralizing their stack, especially their sequencer and their network. Currently, they are securing more than $43 billion in TVL, and they managed to scale Ethereum by a factor of 14. So just to put this into perspective, I think overall, like per day, Ethereum does like 1.2 million transactions, and all the rollups, overall, they do 17 or something like that, 70 million transactions per day. So we noticed that they are managing to scale Ethereum, and this is what we want to see. The transaction fees are also cheaper. Yeah. Going next, I do want to just touch upon the L2 landscape, and specifically we'll look at two of them. So those are the optimistic rollups and ZK rollups. Does anyone know the differences between them, or know about these two rollups? Okay, we see. Okay, so I'm just gonna go through them a bit quickly then, if everybody's familiar. So I want to look at them from 6 different point of views. So the first one is security and how they work. So optimistic rollups are based on a fraud-proof system. So what it means is that initially, like it comes from the name. We optimistically take everything for granted, like all the transactions are optimistically okay until proven otherwise. So the fraud proof system works like everything is so all the transactions are batched, are posted on Ethereum as an assertion, and then for a certain amount of time, it's going to be in a pending state until something like a validator says that this proof or this transaction is fraudulent. So if it's fraudulent, then they will re-execute the whole process again, and then the validator or the one that who mentioned this, they're going to be rewarded, and this is how like optimistic rollups work. Compared to ZK rollups, they work on zero knowledge proofs. I do like to call them validity proofs because they're not technically zero knowledge. So, but how they work is that they have the execution of a transaction or a program or whatever you have. And then besides that, you get the result, but you also generate a proof out of it. And with that proof is being sent to Ethereum, and then the validators are able to verify through a Solidity contract that proof. And if the proof is valid, then everything is okay. If the proof is invalid, then the proof is rejected, and then the state updates is also rejected. In terms of computation, optimistic rollups, they do have the advantage here because there's lower computation overhead. You don't have to create or generate these proofs. While with ZK rollups, there's higher computation because you have to generate these proofs. And then in terms of like development UX or developer UX, as I mentioned, it's easier to develop on Optimism. So, and we'll look at this in the next slide. We'll see the difference between these two, mainly because they're EVM equivalent. So it's easier to develop with EVM equivalency. While with ZK rollups, they are EVM compatible, which means that they have some compatibility, but they're not equivalent. Like not all the opcodes are supported, so there's other things to take into consideration. Networks like Starknet, it's non-EVM compatible, so it purely has everything from different, even the smart contract language, everything like the tech, everything is completely different. And I'll mention why exactly as well in just a bit. In terms of finality, this is where we see a huge difference between the two of them. So as I mentioned, like optimistic rollups, they take a certain period, and this period is 7 days. So whenever you want to exit the layer 2 or like optimism to Ethereum, it takes about 7 days until you reach finality on layer 1. Finality means that on layer 1 means that it's once it's reached, you're not able to change the proof or the outcome or whatever. They need to work like this because that's how like the fraud proof systems are working. And this is a bit of a drawback because again, if you withdraw some funds from Optimism to Ethereum, it might take 7 days, and it's a bit tedious, so to say. With ZK rollups, you can reach near instant finality, but also it depends on the protocol to kind of like set these finalities. Some protocols, they have several hours, or it really depends on how they execute this. In terms of data availability, for optimistic rollups, it's they need to post more data to enable fraud proofs. So once something like a transaction is fraudulent, they need more data to actually re-execute the whole thing again. And then this in terms means more blob space they need. In terms of like ZK rollups, it can be the data can be compressed more efficiently, and they don't need that much data. Scalability, again, here, there's interesting difference. With optimistic rollups, it has to be sequential because of the way fraud-proof system works. But with ZK rollups, you basically can do parallelization, and then you can do like very efficient proofs, like you parallelize the creation of the proof generation, and the whole process can be way faster. It's also like another scalability for proofs is proof recursion. So what you can do is, for example, you have two blocks that state that the output is a certain value. You can create a proof from each. And then from those two proofs, you can create another proof, which basically you create a proof recursion. So, and then you can repeat this for a certain amount of times, and you can scale the whole process very efficiently. This is what Starknet does or has been doing, and we'll talk about that in a bit. Questions so far? No? Everybody on the Zoom is okay?
So basically the advantages of the Cairo are the fact that it costs more to compute, and the fact that I know I might have to switch my smart contract language or not necessarily, or maybe it's not going to be 100% portable.
Right. So the ZK ropes, yeah, definitely. Like with the EVM compatibility, it's trickier, but on the long term, in terms of scalability, ZK ropes are more efficient than optimistic rollups.
And why is it trickier?
Mostly because they're not fully EVM equivalent. Like not all the opcodes are supported. Mainly because how the circuits work. And the opcodes have to be treated differently. For example, for Starknet, it's fully non-compatible, meaning that you have a whole different smart contract language, a whole different stack. So you cannot reuse Solidity. You cannot reuse libraries such as Foundry. You have to create everything from scratch. There definitely good reasons why Starknet went with full non-EVM compatibility, but we can talk about that in a bit. Cool.
Do you think the optimistic rollups will eventually migrate to the DK?
Yeah, I think at one point, I know like there's a bunch of conferences, and sooner or later, the ZK rollups will be the dominant force. They're easier with optimistic rollups. It's easier to get started to develop. Mainly because you have disadvantages, all these advantages, like with Solidity, you don't have to create new tech, and you're able to develop just faster. That's why Optimism was launched in 2021, while ZK Sync and Starknet, they took several years to perfect their tech. But once the tech is being perfected, it's more scalable. Like, for example, I'll be talking a bit like the cool things that we have on Starknet. But I think in terms of like throughput, you can see like 10,000 transactions per second or even higher with the good the upgraded technologies.
One more question. Higher computation means higher fees?
Mainly higher fees. So higher computation means that you need better systems, like system requirements, like a computer. You have to use because it's like it takes much more time to generate this proof. So you have like you execute what happens is that you execute the certain block. Like in that certain block happens like, I don't know, like 100 transactions, and you want to say see what's the difference between the starting point and the end point. And then from out of that, you have to generate the proof. So there's extra time that you have to take to generate that proof, extra resources, and this will technically add to a bit more fees. But what we'll see with rollups is that they can scale so efficiently that the more people use the rollups, the cheaper it becomes. And you can make the fees much cheaper with proof recursion and so many other things.
About the opcodes, as you said, they are different. Is affecting like average Solidity developer if you are not going back to use assembly?
Right. So for example, if you develop on ZK Sync, it might be easier for you to develop, but if you want to develop on Starknet, you'll have to learn a programming language called Cairo, mainly because how ZK circuits work. Yeah, Cairo is technically tuned and optimized for ZK circuits, essentially, to be optimized and powerful for those. Cool. Moving to the kind of like the landscape. So this is where you also see the difference between optimistic and ZK rollup. So you'll see that on the left side, we have the OP mainnet, we have Arbitrum, Base, Blast, and 35 more optimistic rollups. While ZK rollups, they're harder to develop. The technology is much more complicated and complex. And we have Starknet, ZK Sync Era, Scroll, Polygon, ZK EVM, and 12 more. So we can see the differences, like you're able to develop easier on optimistic rollups, mainly because it's the equivalency, but there's some certain drawbacks as well. Like, for example, like the finality that you have to wait. So you have to wait 7 days until you reach finality on L1. Scalability, you'll probably have some issues with scalability in the future. While ZK rollups are better at scalability and overall, like the technology is much more powerful, but it's more complex to develop. Okay, so just in a nutshell, how like the ZK rollups work, there are 3 important phases. So there's transaction batching, which means that it comes to from the term rollup, right? We take a bunch of transactions, we roll them up into a one transaction or one block, and then we process these, and then we send these, we'll send these results to the sequencer. The sequencer will process this further. It will generate a trace, and that certain trace goes to the prover, and then the prover will generate the proof out of it. So we have the transaction batching. So we have the mempool, a bunch of transactions are coming there. They're bundled up together. They're sent to the sequencer. The sequencer executes those, proposes the new block, goes to the prover. The prover generates the proof out of those transactions on the new proposed block. And then once that proof is generated, that proof is being sent to Ethereum, to L1 for a validation. So there's probably a smart contract, like a Solidity smart contract for all the rollups on Ethereum. They verify that proof, and if the proof is valid, then the state update happens and everything is being updated. So in essence, just to recap, there's 3 important phases: transaction batching, proof generation, and then submitting those proofs to L1. Once the proofs are submitted to L1, you have finality. So if what happens is like node operators are picking those proofs up. Once the proof is verified, you have reached finality, and that's about it. With optimistic rollups, it does take 7 days. They're in a pending state, and it takes more. Each rollup in particular has different ways and mechanism how they work with these. So for Starknet, there's a sequencer. There's various modules. So there's a sequencer that takes all of these transactions. They batch them together. They compute and execute these transactions and generate the trace out of it. This information is sent to the prover. It's called Sharp. And then the Sharp basically creates the proof out of these transactions. And then this proof is sent to L1, which is a Solidity smart contract. Now, in terms of differences, do you know the differences between Stark and SNARKs? Or raise of hands? Okay. So Stark is scalable, transparent argument of knowledge, and SNARK is succinct, non-interactive argument of knowledge. So these are the abbreviations, right? So the main differences here between Stark and SNARK is that first, verification for Stark is polylogarithmic time, so it takes a little bit more time than SNARK. SNARK, we have like constant verification. And then the proof size for Stark, it's much larger than SNARK proof. So for Stark, the proof size is around 400 kilobyte, and for SNARK, it's around 288 bytes. So technically, if we're looking at this, we say maybe SNARK is better because you have constant verification and the proof size is smaller, right? But there's 3 more important factors that makes the whole difference. And these factors are the proving time. So the proving time for Stark is actually a few seconds, while on SNARK, it takes about 10 to 30 seconds. So there's a difference of 10x in terms of scale. In terms of, so proving time is the generation of the proof itself. In terms of trusted setup, so trusted setup, it means that if you want to, so for example, for a SNARK, you need to have like these trusted setup like KZG ceremony, or for Zcash, I think it's power of Tau. You need to do this trusted setup in order to maintain privacy for the proof generation. And the thing is that it consists of, initially you have some initial parameters that are being randomly chosen. You also have toxic waste that's being used. And these all parameters are used for creating that proof. However, there's certain caveats. So the system is secure, but it's not bulletproof. What I mean by this is that if, for example, the machine that these initial parameters are generated is compromised, then the whole setup is compromised. Or if the toxic waste that's used for these trusted setup is not disposed properly, again, it's being compromised. So there's a lot of things to take care of if it's not properly handled. While with STARKs, you don't need a trusted setup. That's a huge advantage. And finally, the quantum secure. So STARK is based on hash algorithms and they're quantum secure, while SNARKs, they are not. So probably in 10, 20, I don't know when exactly will happen. At one point, we'll reach this quantum issue, and this will be a problem for blockchain in general. But with STARK, you have quantum security, so we can handle that.
Basically, because of the trust that for SNARKs, it makes the whole system quantum insecure.
No, so for STARKs, it's they are based on hash algorithm, and it makes it more secure with quantum secure. So, and because we don't use trusted setup, we don't need these initial parameters, and the whole process is safe.
Yeah, I was referring about SNARKs.
SNARKs.
Because the trusted setup makes the whole system of SNARKs quantum insecure.
No. So the trusted setup is something different that they have to take care. The quantum secure, they're based on a different algorithm, which makes it not quantum secure. So the hash, there's basically the hash families, and then STARK is based on those hash families. And because it's using these hash algorithms, they are proven to be quantum secure towards this.
There are specific, like, suppose like Ethereum or Bitcoin is also based on hashes.
Mhm.
So I guess there are some specific hashes algorithms that are quantum secure.
Yeah. For example, SHA-256 or Poseidon, you have these hashes as well. Okay. So now the question comes, like, why Starknet? And Starknet has so as I mentioned, it's totally non-EVM, which means that initially, like, it was a very difficult bet. Like we had to create everything from scratch. It was basically like we had to create the technology from scratch, the language itself, the community, everything. So it was quite a difficult bet to make. But overall, we decided that we are focusing on the right technology and make it scalable. I do want to mention, like, what of the reasons why. So the first thing, we've seen this with the CryptoKitties. So we have the L1 scaling problem. So just to give you like an example, we have a node operator that's being picked to produce a new block. And let's say like a bunch of transactions happening. The node operator executes these transactions and states that the new global state of this block is 42, right? So what happens in Ethereum is that other node operators, they don't believe you, right? So they will re-execute everything from the beginning, right? And this is how the consensus algorithm works, and it's a secure way to do it. However, it does impact the overall efficiency of the network. So by re-executing the whole process again, it does take time to reach consensus, and then this could definitely incur some slow. But overall, like the consensus on Ethereum worked, and nothing severe happened so far. It's yeah. But on Starknet, what happens is that we have this phrase execute once and verify everywhere. So you can notice even on the screen, you have the block itself. Again, we have the new state, the new global state 42. However, you see those small dots, you have an extra computation that happens there, right? So this is what happens on Starknet. There's extra computation to generate that proof. But we from this new global state, we also have the proof. So what happens here, we send those proof to layer 1 to Ethereum, to a smart contract, the Solidity smart contract, and all the validators will pick that proof up, and they will verify the proof itself. So when they verify the proof itself, if it will only take a fraction of the computation of the actual execution. So this helps to scale the whole network massively, and allows faster execution and scalability in that sense. This is the execution versus verification, just to illustrate. So for example, like the sequencer on Starknet takes like X amount of time to execute those transactions. However, the validators, they only the certain validators, they only have this fraction of the actual execution. And this number is polylogarithmic, so it will take you log square x to verify these proofs. And just to illustrate as well, what we have here is that with improved recursion, this can get better even. So what happens is that you have, as I mentioned, you can have like, let's say, 8 different global like blocks, and then you create a proof out of those, and then from those proofs you can create a recursive proof, and then you can recurse again, and so on. Like I think the depth of the recursion it could go a lot, like 60 something or something like that. But yeah, it's quite efficient, and it helps to make the whole network cheaper and more scalable. Now, there's a pyramid there on the right, but none of this wouldn't be possible with Cairo. And Cairo is not a city. And also it's terrible for SEO, because if you try to Google something on Google, you might book a trip. But Cairo, basically what it stands for is, so C stands for CPU, AIR stands for arithmetic intermediate representation, and O is added as a flair, so to say, because otherwise it will be Cairo. So that's how Cairo ended up to become. Again, terrible for SEO. Hopefully this will improve in the next few months, years. But yeah, it's not like everything that I mentioned wouldn't be possible without Cairo. So what's Cairo? Everyone heard about Cairo? Maybe a raise of hands. That's good. That's good. I'm excited to see that. Cool. So there's a couple of things. So first of all, enables verifiable computation. So what does that mean? Basically, let's say you have a program, right? It's a Cairo program that executes, I don't know, like Fibonacci, and you want to find out Fibonacci at 16 or whatever. It outputs the result, and you have the result. I have no clue what's Fibonacci of 16, maybe 200 something. Yeah. But on top of that, Cairo generates a proof, right? So you have a proof generated with that output. And what you can do with that is that you have the output, but you also have the proof that you can send to anyone else, and they can verify the proof, and they can say, indeed, the output that you have is the correct output. Nothing has been changed in the execution, nothing has been tampered, so you can be sure that the result that you get is valid. If it's invalid, it would show in the mathematical proof. So there's only like mathematical proofs. Under the hood, there's a bunch of polynomials that works together, and you get this verifiable computation. On top of it, Cairo runs on top of Cairo VM. So Cairo VM is the Cairo virtual machine. We needed to create a whole new architecture for Starknet, mainly because it has to work with these ZK circuits, and Cairo VM has been specifically been optimized for these ZK circuits. I have no clue how to do ZK circuits. They're very complicated. There's a bunch of things that you have to consider. But what's nice about Cairo is that everything is abstracted. Like as a developer, you can code like in simple Cairo language, and everything is being taken care of the compiler. You don't have to take care of it. The syntax is inspired by Rust. So maybe some of you developed in Rust. Okay, that's cool. So if you know a little bit of Rust, it will look quite similar. I'll show an example in a bit, but yeah, it's inspired by Rust, and it also inherits the ownership model. And it's strongly typed, it has traits, macros. So the smart contract language is quite robust. And to be honest, I believe at one point it started to become even better than Solidity because there's certain things that you can do with Cairo, and offers overall like a better developer UX or experience. Now, the nice thing about Cairo is that it can be used outside of Starknet. So you don't have to necessarily, if you want to develop proofs or if you want to create proofs, you can use it anywhere else. You don't have to settle on Starknet. Starknet is using that, is using Cairo, and you can use it for Starknet. But in case you want to create an example of a program that you need the proof out of it, and then you can verify this proof somewhere else, you can use that. So that's the nice thing about Cairo, that you don't have to stick with Starknet. And finally, as I mentioned, you don't need to know about any zero knowledge or zero knowledge circuits. Everything is abstracted from the developer. So yeah, it's quite a fun language. I'll show just a quick snippet in just a bit, and hopefully you'll think the same. I know like new languages can be scary, but yeah, there's a whole history of Cairo, because initially, so Starkware is the one that actually created Cairo, and just a small parentheses, they initially created Cairo internally because they needed to write these polynomials more efficiently. They were writing them, I think, in by hand, and to write them efficiently, they created Cairo 0 that we call it today. It was a very low-level programming language, looked like Python, but you had to take care of a lot of things, and it was very difficult as a developer. Documentation was a little bit hard as well. And what happened is that there was a transition phase to Cairo 1, which is currently now Cairo, and the language is way better. It has this Rust-alike language, and the overall experience improved quite a lot. And that was small parentheses. Okay, now in terms of finality, so we can look at, so Ethereum usually achieves finality in 6 minutes, which is quite fast. For Starknet, so this is, we're talking about layer 1 finality, right? So layer 1 finality on Ethereum, it's 6 minutes. For Starknet, the finality on layer 1, it's around 5 hours. So maybe your question is like, why it's 5 hours? Mainly because there are these recursive proofs that happen. And to make it more efficient and more like cost effective, there's a bunch of recursiveness happening, and then a big proof has been sent to Ethereum, and that's why it takes so much. The finality on layer 2 is 2 seconds. So if I send a transaction, the next 2 seconds reaches finality for layer 2. And then for optimistic rollups, the finality for L1 is roughly a week, because they're this pending state until proven otherwise, or the 1 week passes.
Is affected from this time about decentralization? Like, does it matter?
That's a good question. I think that's a good question. So when decentralization will come into place, this might change, but I think the number will still remain the same. So for example, with decentralization, a lot of L2s are working on decentralization. For Starknet specifically, it will be Tendermint. And what happens is that the whole stack will be decentralized. And the finality, I think it will be roughly the same, or yeah, I don't think it will change much.
which one is better than Starknet, for example?
For the layer one finality, or
Yeah.
which one? I don't know. That's a good question. I haven't checked for other L2s, but initially, like even like for example, Starknet could technically have layer one finality in 1 hour if they want, but then the cost of the transaction will be higher. So there's some trade-offs that you have to do. Like you have to like whenever you're building these systems, there's some architecture choices that you have to pick, and then this would be the most optimal one. There's a like if you want to have finality every, let's say, block, then you're gonna have to post a proof every, let's say, 5 seconds, but it's gonna cost you more in terms of like transaction fees.
So probably it's a ZKO.
Sorry?
Probably a ZKO.
Yeah.
You can check on L2bit. There's a whole section about finality and how they achieve it and how fast.
Yeah, L2bit has a bunch of information about like activity, TVL, TPS, stuff like this. Yeah. Okay. Now, regarding TPS, so I don't really take TPS as an actual metric because I think it's a really bad metric, but the whole network likes TPS. So in terms of like Starknet's performance, I think in October 29, there was a game called Flippy Flop. And it was a fun game. It kind of like proved the like the whole UX with account abstraction, and then an interactive game with I think it was called like players versus bots. So the players would have to flip a tile, and then the bot, like the evil bot, would flip it back. So there was a constant battle between the communities and the actual bad evil bot. But anyway, during that time, the network reached around 857 TPS. Was a major improvement for Starknet. And I think the average TPS throughout the day was 110 or something like that. So it shows on L2B as well. You can check it by yourself on Voyager and StarkScan. These are the two block explorers that we use. And the network itself is scalable. We do have a bunch of upgrades coming up, which will even make this metric higher. Now, why I said TPS is not really like I don't like TPS as a good metric is that a transaction for Starknet could be a multi-call. So what the multi-call is that I can bundle multiple calls towards a contract, and I can make it as a one transaction. So it doesn't really show the actual, how do you say, metric behind it. But we almost reached 900 TPS on mainnet, and in the future upgrades, this will be improved even more. Transactions are cheap. So I think this was taken in the 2nd of February. So roughly a transaction would cost you like 0.007. As a user, this is really good. Like if you try to, so whenever like Ethereum is congested, like, I don't know, Trump coin comes in, everybody wants to buy it, and you want to trade on Uniswap, it takes you like $20, $40, $100 to actually pay for like a swap or something like that. If we want to scale and make it like accessible to everyone, we need to reduce these transaction fees. And that's the aim of Starknet and other rollups, to make the whole process way cheaper. And one thing that I do want to mention also, it's smart wallets. So anyone heard about account abstraction or the concept of smart wallets? That's perfect. Oh. Right. I'll let you talk about it, or right. Okay. So smart wallet. So I think so overall, like, so the issue with Ethereum is that it's the traditional EOCs, externally owned accounts. And what happens is that the signer and the account, they're coupled together. So with smart wallets, these are decoupled. So the signer and the account are decoupled, and there are interesting things that you can do. So the account can act as the smart contract itself, and then the signer would just use some certain functions from the smart contract to verify the signature or do things like this. So what happens here? You can create better UX for the users, right? what does this mean? You can have multi-calls. So if you go on Uniswap, you have to, if you're trading the first coin, you have to approve it first. So that's one click. And then you have to swap it. That's another click. So there's like two step into something that should be just one step, right? With multi-call, you can just bundle these together, and then the user would just submit one call. Then there's hardware signer, which kind of like adds extra security. So you can have a hardware signer. It could be your phone, it could be your laptop, it could be anything else. You can have social recovery. So again, this is all possible because these are decoupled, and then you can create this programmable logic on the account. And you can have social recovery. So for example, Argent has something called like Guardian. And then if you create an account, you lose access to your account, you forgot your seed phrase. Even seed phrases are terrible, but if you forgot your seed phrase and you don't have access to it, you can have your Guardian recover the account itself, which in like traditional wallets is just terrible. If you lose your seed phrase, you basically lost access to all your funds. Session keys. Session keys, I'm a big fan of session keys because I've been a gamer, and I don't know if you've seen some of the games that every time you do an action, you have to sign a transaction. And it's so annoying because it's like, it just cuts out the fun. So you're like super focused, you have to sign a transaction. You want to kill something, you have to sign it. So session keys, what happens is that it gives you a limited amount of scope and permission towards the contract or application or that. And you create this session and they will be able to sign and without interruption, you'll be able to play the game. So it's quite good. It could be applied to any different dApp, doesn't have to be games. There's Paymaster. Paymaster, again, it's a cool feature. So as a application, I can incur all the fees from the users. The users don't have to take care of like, oh, I don't know, let's see if I do I don't know, like a shop or whatever. I don't have to take care of the fees. As a user, I just want to browse, I want to buy, and then I don't need to know about like, okay, this is this amount of gas fees, or should I wait maybe a couple of hours to maybe go down? So it's quite a nice feature. And all of this is enabled by account abstraction. And what's nice about Starknet is that this is currently natively supported from day zero. From day zero, there was account abstraction, and there's a lot of cool features that we have. So for example, there's, I think, the cartridge wallet that basically it operates on a passkey. So you just create an account, a passkey is saved, and then you'll be able to play the game. It has paymasters incorporated, has session keys incorporated. There's a bunch of cool things that you have, even achievements. So your basically account have like mini achievements that you can have. There's Argent, Bravos, Kepler as well. So they all are good wallets on Starknet. Yes, all of this is basically, so there's a specific interface for all of these accounts that have to follow. So it's called SNP6. I won't get into details, but you can think of SNP6 as like EIPs on Ethereum. And all of the accounts have to follow this specific interface. And yeah, there's support for signing a transaction for different elliptic curves. So and then on Starknet, everything is a smart wallet. There's no EOAs. So yeah, any questions here? Cool. Yeah. Sorry? The session keys, you mean, or?
We're actually investigating that Argent before Ledger has the native Starknet app. We're investigating how we can integrate Ethereum Ledger app and use that as a key to sign Starknet transaction that has a different.
Also, you mean the elliptic curves? Yeah. There's also like the forgot it basically allows you to have a sign like on mobile as well, which allows you natively to use them as wallets. But yeah, you have the standard elliptic curve, you have the Stark elliptic curve, and then you have the SEC 256, something like that. That's basically for native mobile wallets. And what happens is that I, as a signer, I can use that and also have it in my what's it called? Secured enclave for iOS. I think I can use that, and I can sign transactions and process this. Okay. Now, some exciting updates for this year. There's a bunch of them, but I'll just mention some of them. So Cairo Native, maybe this was all new to you, but Cairo Native basically will allow us to completely bypass the Cairo VM and execute native CPU opcodes. This will improve like the overall performance of the network. I think the metrics are at least by 2x. Then there's this so Stew Prover. It comes from Stone 2 Prover, and it became Stew. What's currently in production is called Stone 1, so Stone Prover, and that's been in production since like 3 years now. It has been securing over 3 billion TVL of transactions happening, and then other like companies are using it, and the Stone Prover basically has been in production and quite successful. Now, compared to Stew Prover, Stew Prover is basically the next gen open source prover. It's based on something called Circle STARKs. It's a different field. It's M31 field. It's Mersman field, and they're more efficient than the field that Stone Prover use. Stone Prover uses Feld 252. And just to give you a comparison, the metrics show that Stew Prover is at least 1,000 times faster than the Stone Prover that we have. So once it's already open source, you can already create proofs. There's actually recently there was a workshop given by Starkware, and it's super fast. So there was like some testing done, and they were like proving some hashes, and the speed of it was quite amazing. So this will definitely improve the network overall, and we will see this scale the whole process way faster. And then there's other couple of upgrades or updates. So mempool, currently there's no mempool on Starknet, so everything is first in, first out. But at one point, mempool will be added, a fee market will be added as well, and then this will basically benefit the users overall, like the experience. If you want to process your transaction faster, that's possible, or not. Yeah. So and also you have 2 seconds blocks. So I think currently the block creation is, or how much does it take to create a block? It's roughly 20 to 30 seconds. Which is good, but this will be further reduced down to 2 seconds. It will benefit a bunch of apps as well and games as well to have this improvement. Then there's the decentralization. So we're currently in the decentralization. There's a 4-step phase of decentralization for Starknet. The first one was introducing the permissionless staking and delegation. The next phase, I think it will be in Q2. Which will basically mimic validators. And then at the end, in phase 4, the node operators and the validators will have full responsibility of the whole overall network. As I mentioned, we will go with the tender mint. The decentralization process is very complex. And the way it does it, it will try to decentralize every bit of the stack itself. And I think for myself, client-side proving is quite an interesting upgrade. So client-side proving will unlock a lot of interesting things, such as the case of I can run my whole program on my machine. I can create privacy with it. I mean, you still can create privacy with this, but there's better privacy like that. You can create the proof on your machine. You send this proof to the network, and then everything is processed. So for privacy, you can create interesting applications. For games as well, you can start unlocking games that have high FPS, or like shooters or something like that. Because currently, if you develop a game on like any blockchain, you still wait for this block confirmation, and it's like every 2 seconds. It's very, very slow, let's say, right? So you can, in terms of games, you can think of like you play the whole, let's say, game as a level, and once you finish that level, you send this proof to the network. If the proof is valid, if you haven't cheated the game or whatever, then the rewards are unlocked. So definitely a bunch of new interesting things are coming.
So the client, is the client required to have, I don't know, some minimal system requirements to run proofs? It's complex, meaning because one of the disadvantages of secure rollups is that you have to consume lots of compute.
Yeah.
Okay, so but if some of the computation is done locally on the client, and it's probably pushed and just aggregated by the sequencer and so on.
Yeah.
It's still computed on the client side, so it means that I should have some computation power.
Yeah, so with StuProver, actually, this is like improved. Like it's StuProver is being optimized for like creating, like generating these proofs, and like I think like they're able to like create like proof. I don't know how much was in terms of metrics, but a lot of like anyway, I'm forgetting the metrics, but overall, like what matters is that the StuProver and Circle Starks are way more efficient. It's like 1,000 times better than the Stone Prover that we have, and you'll be able to like create these proofs efficiently. So I think like even like a normal machine of like normal the requirements would help. I don't know exactly what will be, but the aim is to be able to generate them on the mobile as well, like or mobile phone or something like smaller devices as well. It will be quite powerful. Like it's quite powerful, and yeah, I have somewhere a slide with how many Blake hashes have been proved. I think there's like 600 something thousand Blake hashes in 1 second, which is quite fast, and it was done on like an M2 Apple or something like that. But yeah, it's quite interesting. It's like the client-side proving will unlock a lot of things. And as I mentioned, there's a workshop. You can actually test it out. It's quite simple to do. Like there's a package called SCARB, and then you can create your program, you can create your proof, and you can verify the proof with it. So it's quite, we tried to, initially with Stone 1, it was a bit difficult because first it was in C++, I think. And then the second wasn't necessarily straightforward how to use these. And with Stone Prover 2, Stu, it will be much simpler as a developer to generate and create these.
Would all the transactions be client side proven, or some of them would be client side proven and the others would be still classically proven by the and in that case, how do you end up sending a single thing and the
Right. So basically like the finality for transactions is like 2 seconds. So whenever you create like this proofs on the client side, what happens is that you will send it to Starknet, to the mempool. The mempool receives it, it knows that it arrived. Then the transaction is being processed by the sequencer. And then you will reach finality of that transaction like roughly 2 seconds. It might be improved in the future. I don't know exactly. I have to ask the people from Starkware, but the finality on L2 will be reached in just 1 or 2 seconds, and then the finality on layer 1 will be reached in 5 hours or 6 hours.
The recursive method, or is it somehow set separately?
Right, so that's up to the like developer itself how they do these client-side proving. So for example, you can send like every time you it depends on the developer. So I think how it works, like if you develop the game, you can send it per levels. You send a transaction to the, once you finish the level, you send the proof. And then on the Starknet itself, these are aggregated and have the recursive proof. But on the client side, it's up to you to decide how you want to define these. Like you can send a proof every minute, every level. It's up to the like that developer how they want to create this architecture. It's still like state of the art. I know like the people from Starkware and Cartridge are working on this. I think we'll try to, they already like sent some proofs, tested some proofs, and we'll see maybe in some of the upcoming games to be tested out to see their power. Okay. And just to show like overall like the ecosystem, so there's a bunch of applications, projects being built. It's quite initially like my journey into Starknet is I came for the cool tech. I've heard about many interesting applications like the Cairo language, the technology that Starkware and Starknet has been developing. But then for me, the ecosystem kind of like made me wholesome because like the ecosystem is so friendly, helpful, and a bunch of folks like people are comparing it to, I don't know how it was for early Ethereum community, but people would compare it to early Ethereum. So there's a bunch of projects being born. I think this is kind of like an outdated ecosystem. It's from November. From there, like we have a bunch of others. But you can see also like the gaming ecosystem where like the projects are growing. There's a bunch of things that you can do on the gaming side, mainly because there's an engine called Dojo Engine, and it offers developers to create these interesting games and more like heavy compute games. Yeah, so I do invite you guys to explore it, to see it for yourself. It's quite an interesting ecosystem overall. Okay, so just to give you a quick summary on why Starknet. So again, as I mentioned, it combines the power of provable execution with the transparency of an open ledger. There's the Cairo. It's a powerful programming language. It's which helps us to create these ZK proofs under the ZK circuits. All of this is optimized for the ZK technologies. And what's nice about this is that it's secured by the STARKs proof system, but also by Ethereum itself, which inherits its decentralization, transparency, and security. So in the end, we settle on Ethereum. It comes with native account abstraction. So there's a bunch of new features that you can create. I think the important point is that once we try to onboard the Web2 users, we need to make it as simple as possible. I know like in today's society, like if you're a Web3 user, you probably have like 7, 8 wallet extensions installed. We need to make this process way simpler. There's terms called like invisible wallets. Users don't even have to pay attention of like wallets. You can create all sorts of things. And then finally, what's important is that you execute once and verify everywhere. As I mentioned, you have this execution, you create a proof out of that execution, and then you can send it to Ethereum to verify it everywhere. That's kind of like the summary of Starknet. How are we doing on time? 44. Yeah. I just wanted to show you like just a quick example of like a smart contract and like to show you like how friendly it is. So this is let me just quickly get out of here. So I do have here like a complete like fresh VM. So just for the sake of it. And I'm updating something. That's not good.
We have some questions until then.
Yeah, let's have some questions. Any questions from Zoom or from the audience?
How is Cairo compared to Solidity in terms of developer experience and efficiency?
So in terms of developer experience, I believe like Cairo has come a long way. Obviously, it's a completely new language, so it's more difficult. For example, if you want to develop on Optimism, it's going to be Solidity again. It's going to be easy for a Solidity developer to go there. But in terms of like experience personally, I think the Cairo language is more robust, more secure. It's more dynamic, so you can create certain specialized macros that if you want to, that helps you to create these abstractions. And overall, I think it's better than Solidity. It keeps improving compared to Solidity, but I can probably try to show you in just a second. So let me see if what do I need to do here? Right. So there was actually, just give me 1 second. Software mention. Right. So software mention just created like like one line code. Just let me see if I can quickly see it somewhere. Yes, code scarb, Stark up. Yes. So this is one. So basically, there's a couple of libraries that you have to install. So one of them is called Scarb. So Scarb is something called like a package manager. It's not this one though. Scarb. It's a package manager that it's similar to Cargo. Yeah, exactly. And basically allows you to install other libraries, dependencies, things like this. Then the other thing that you will need is SN Forge, or Starknet Foundry. Starknet, let's put it like this. Starknet Foundry is similar thing as Foundry on Ethereum. It's a tool for testing. So it allows you to test your contracts, but also it has a CLI to deploy and interact with your smart contracts. And besides that, we have something in the chat. Any questions? Okay. Got it. And then besides that, maybe you'll have to install like DevNet if you want to. So there's Rust DevNet, Starknet, Rust DevNet, but essentially you just need Scarb and Foundry to get started. So I'm just gonna come here. So there's a simple curl command that you can use and then install all the necessary dependencies. Not good. Hope the internet is fast. Let me see if I can make this. Okay, let's see. Start, yes. Okay, I do have to run a new terminal, so I can exit this. So now, like, we install all the necessary dependencies. And then besides this, you'll probably need an IDE. Let's give it a couple of seconds. I can take any questions in the meanwhile.
So, my biggest problem as a farmer and also the developer that again wasn't classically being smart contract. And it's hard to me when you check. My question is like, as arbiters have developed arbitral styles, do you plan to do something similar for Solidity? Like, I mean, this is the only reason my smart contracts are not on Starknet, and it's a bit difficult to move on.
Right. So for the audience in the Zoom, the question was, so it's a bit difficult to move to Starknet because it's a whole new language, and if there's any plans to do something similar as the Arbitrum stylus.
So even if I'm planning just to like translate the code, like like design and everything, I still need a new audit that cost me a lot to deploy.
Yeah. So Cairo, like initially Cairo, Cairo won't be on like an extra library like stylus as for Rust. It does come similar as Rust. So if you already know the Rust, picking up Cairo would probably take you 1 or 2 days. The same concepts apply. Now in terms of like, there was a project called Kakarot, which they developed this where you could convert basically Solidity code, run Solidity code in Kakarot, and they basically would just transpile the bytecode to Cairo. I believe they have paused that process for now because the network won't be able to hold the amount of like TPS and things like this, like the activity. But once the Cairo native and the Stu prover comes into play, they might use that again. So basically, Kakarot, you will be able to use Solidity codes into Cairo without even writing Cairo. But yeah, I don't think there will be plans to actually create like a library like Rust. It's purely Cairo, which is similar to Rust, and yeah, I think as a developer. So for a Solidity developer, I think Nethermind mentioned this. It would take roughly 2 to 3 weeks for a complete Solidity developer to switch to Cairo. But if you know Rust as well, it will probably take less than that. developing in, yeah, I'll show you just a couple of examples. So just give me any other questions? So I have here a SCARB version. Let me see. So we see it's 2.9.2. Can you guys see, or is it enough? And then SN Forge version. So yeah, so basically there was just a one-line command that I had to run. Initially, you would have to install these. So what we use is ASDF. It's kind of like a live package that allows us to switch versions between different packages. It's super simple. And then we have SCARB and Starknet Foundry. So initially, this was it. I can start creating like on my side on this terminal. I have different shortcuts. Like if I go to Linux, I have completely different shortcuts. But just to showcase here, so I'll create, let's say, configure demo 2. Demo doing. Thinking in Romanian English, just note. So we say scarb new, and then here we say the package name. So we can say ETHCluj. And then we can choose like which type of like test runner we want to have. And we have the Starknet Foundry, or you have the native Cairo test. So we'll pick Starknet Foundry for this case. It will download everything. So it just takes a little bit. And once we have that, we can notice the file itself. We can just go inside it and then open the project. So let's see. So what happens is that we have a couple of things. So we have the SRC, which is the source folder. We have SCARB TOML, which is the cargo TOML. And then if you take a look here, it's just basic things like you have the package name, version, and edition. You have the dependencies. So if you want to write smart contracts, you have to add the Starknet as a dependency. Otherwise, you would just write vanilla Cairo. And then here we have the development dependencies. These will only run when you develop or like test. So we have Starknet Foundry and then some server macros. And there's other things here that like Sierra is something called safe intermediate representation. So what happens is that you compile Cairo to Sierra, and then the Sierra is sent to the Cairo VM, and then the Cairo VM will compile it down to native Cairo bytecode. That's what happens. Initially, it was just Cairo bytecode directly to the EVM, to the Cairo VM. However, this had a big issue. In case of the execution would be invalid, like for example, the transaction will fail, the sequencer wouldn't be able to be paid because the transaction would be rejected, and then the sequencer wouldn't be able to process that. So it would open like a DOS attack of a denial of service, and you could basically like how to say like the sequencer wouldn't be paid for the DOS, and it could incur like a financial attack. So this is why Sierra was coming into place. Sierra is able to handle these rejected transactions, and those rejected transactions are able to be processed on the network and included in the network itself. Parentheses. Anyway, so this is your standard code. I think this is a bit too big. So what happens is like you have the interface or the ABI. These are the macros that I mentioned. So the macros are kind of like abstracts a bunch of code for you, and it tells to the compiler, hey, treat this specific function as an interface, or treat this specific functions as a contract. So these are the macros, how we communicate to the compiler. This is the public interface. Hi, hello, Starknet. This is like just boilerplate code. And we have two functions, increase and get balance. Now, maybe a question for the audience. Do you guys know what's the difference between the two? So you notice there's a ref self T contract state, and then there's a self at contract state.
One create a transaction, and one won't.
Sorry, one won't. Okay. Yeah. Yeah. Okay. Any other guesses? Yes. So with one similar thing, like whenever you read, what happens is that you're just querying the like the full nodes, right? So you're querying the result. You don't really interact with the Starknet network. You don't modify the state of the network. But the other one, it's a write method, because I changed the state of my contract. So for example, maybe in the contract itself, in the storage, I have something called balance where I keep a number. And whenever I want to change this, I have to change the global state of the contract, right? So for that, you'll also create a transaction, because whenever you want to change the global state, you'll have to pay a fee for it. And then this is the difference. So the increased balance, whenever you have the ref self, you will have access to the contract state and you'll be able to modify it. You can have like these write functions, but whenever you have the at, is just a copy of that contract state and you won't be able to do anything to it. So you'll be sure that if I try to do here like a write method, the compiler would give me errors. I won't be able to compile my code. And this is the type safety that I mentioned. So it has type safety involved.
Do you have a limitation to read data? For example, if I write a huge getter that gives me a lot of data, you have a limitation with gas, I don't know, maybe solidity is 7K gas or something like that.
You have a limitation to write. So it's called something like, just give me a second. It's called Cairo steps, which is basically like the amount of compute. And where is it? Resources.
So when you're saying right, like you're referring to one transaction.
Not found. For topics. Tokenomics. So there's actually some so for, let me see if I can chain info maybe. They recently changed the so here you have, so basically like the transaction limit. So you have a maximum transaction size, and which allows you to write 10 million Cairo steps, both on Sepolia and mainnets. And this is how you actually measure like the amount of compute that you need to do. So you would be able to write this, and then the same applies for the read, because if you cannot write more than that, you won't be able to. Any other questions? Yeah, so this is how simple contract looks like. This is how where we denote the like contract itself. Here we have the storage. So the storage, each contract has its own storage where you can keep like variables and all the logic for your contract. Then this is the implementation of my interface that I have defined here. So whenever you create an interface, you can say like, okay, I'll have like two functions. I'll have increase balance and get balance, right? I define them here at the top. These are public functions that other contracts or users can interact with. And now, like in my implementation, I need to define the code logic. So how do these functions work? So for the increase balance, we'll notice that there's a write method here. So this will basically read the balance, and then we'll get the amount. And then for the get balance, it's just a simple read. Even if I try here to say self balance write, and then say, I don't know, like 10, and let me put like this, you will see that the compiler would, and then move this, let's say like this. It will compile, because it's like, I'm not able to implement a write method on a read function. So you have the complete, you always have this error at the compile time.
Do you have custom errors?
Custom errors. Yeah, I think you can implement custom errors as well. So I believe so. Yeah.
For the events, you have like that is depending on the events. Does the events works similar to the end?
One more time.
So about the implementation of events.
Yeah.
Yeah, it works similar to Ethereum, for example, because I'm asking for that require the graph, for example, to process the data for events.
Yeah, they work similar as Ethereum. I mean, I can even show you like on the Stark scan to see like, let's see an event here. We're just gonna grab a transaction. hopefully they emitted an event, and then you have the events here, and then you can query these. Like you can use indexers, and then you can I think you use the graph as well, and then you can get these events, and then you see like the approval event has been triggered, and then inside this event you will have like whatever you decided. So you have
the main difference is actually the syntax, not the.
yeah. I mean, the logic of a smart contract is a bit the same, although here you have other nuances. So everything is immutable by default for Cairo, and it inherits like the ownership model. So once you like pass the ownership to another variable, then you lose the ownership of that variable. Like Rust, for example, you have let A take this ownership, and then I cannot use anymore, like let's say, let's put it this way. Let me put here. So let A equal to 10, right? Let B equal to A, and let C equal to A. Now the thing is like I cannot use let C equal to A because I already passed the ownership here towards it. So you have to make them mutable, and like this is like the ownership model. Like once you pass it to the other one, inherently you lose the ownership. It mostly comes from Rust, and it's more safe to do it like that. Yeah, the nice thing about Cairo as well is like you have these macros, so you can also like create your own custom macros. So if you for example look at Dojo Engine, the Dojo Engine, it's a tool to help game developers to develop their own game. They consist of quite a lot of cool things. And we have this Dojo starter. Let's see. So you can see now, like you can see, okay, it's not Starknet contract, it's a Dojo contract. Why? Because they define this macro differently, and how Dojo works is they have like this ECS architecture for games that's based on entity component system, and they could like remodel the whole thing according to their specifics. There's a bunch of things you can define Dojo events and so on and so forth. So it's like highly customizable and quite powerful as well. But yeah, this is mostly that I want to show you. I mean, we can deploy it as well on the network, but I think we can skip that. I'll probably invite you to one of our base camps. I'll talk to that in a second, but maybe if you have any questions about Cairo, feel free to let me know. How do you guys see it at the first sight? Is it?
We have standards like BRC.
Yes. Yeah, so like you have from Open Zeppelin, we have these standards, and the nice thing about this is that they work as a component. So components are kind of like blueprints, and I can take this blueprint and reuse it throughout my contract, as many as I want to. Like for example, let's say you want to create a ERC20 token. And then this is the implementation that you have to, like you basically create the component here. I mean, this is the whole code to create a token. That's basically it. This is like the component structure, and then you inherit this blueprint. You initiate this blueprint in your contract, and then you'll be able to create it. So
does blueprint affect the storage? I mean, the storage of the smart contract. For example, when you import libraries on EVM,
right.
In fact, how big is the smart contract?
Yeah, so components basically they become part of the main contract, become like when you compile it down to Sierra, it just becomes part of the code itself. It depends on you what type of components you want to integrate. You can create your own components as well. Like for example, let's say you want to create game is super simple to use as an example. You want to create a game that has this component of creating a character, and you want to reuse this across your code. You can create that. Or you can use Open Zeppelin, their standard contracts. You have ERC 721, you have the security stuff, so you have everything here. It's quite customizable. But if you want to use like specific calls like libraries, so this is a bit more advanced. There's something called edition 2024-07. This is kind of like the prelude that it comes with only the essential libraries. And then as you go and develop your contract, you import those libraries and those become part of your contract. You can use another edition, it's called 2023. This comes with all the libraries, but technically it will be, your contract will be a bit bigger or in terms of like. Yeah. Oh, you have like the, yeah. So you have the upgrade here, and what basically becomes is like you replace the hash of the class, like class hash. You replace the class hash. You initiate this function in your contract, and whenever you deploy a new contract, you replace the class hash, and then we'll point to that new contract.
It's like a proxy.
Yeah, like a proxy, yeah. Yeah, it's quite straightforward. You have this, and then if anything changes to your smart contract, you maybe decided to change the function or whatever, the logic, you'll deploy it, you receive a new class hash that you deployed, and then you'll use that in your old contract, you'll upgrade it, and that's it. Like a simple proxy. No worries. Any other questions?
Structure related questions. So, could you explain on L2 a stage that Starknet is in and which of the component and what the plans are related to?
Right, these are always confusing to me. Like, I don't think I can properly explain it. So sequencer failure, there's no yeah, I might be able to check this out and then come back to you.
Let's take the sequencer. So the idea is that there is this intent to decentralize it, right?
Yes.
And how would it look in the final architecture? Basically, in the end, you still end up with a kind of a network of nodes.
Yeah.
That have to have some kind of consensus algorithm. And they all, as a network that communicate through a consensus algorithm, agree to state and then push that state to L1. So basically, this is the way that I see it. I don't know, it's just speculative.
Yeah, it's a good question. I'm not that familiar with the whole decentralization topic, but from what I can think of is that all the node operators will be able to like act as a sequencer. They will be picked, for example, and then they will produce like the new block and whatever. And I believe like the rest of them, they won't re-execute the whole thing. They would just verify the proof that was generated. And then that's how the consensus reached. But I have a good documentation on it. I can send it to you regarding it. But the whole process is quite complex because decentralizing rollups is not straightforward. There's multiple components. So for example, you have the sequencer. There's a Cairo OS that there's this like a Cairo contract that operates that needs to be also integrated. There's the shared prover Sharp that creates the proof. So there's multiple modules that need to be decentralized, and it's a complex situation. But I have a good documentation. I'll send it over.
What about bridging when you want to send from L1 to the L2? You have a info from the main messaging system or someone in the sequencer? Or
so like what's the questions like?
do you have like a messaging system inside the?
Yeah, so it's L1, L2 messaging and L2, L1 messaging as well.
Also L2 to L1?
Yeah.
Okay. But that's 5 hours, right?
Yeah.
And the L1 to L2? It's fast.
Quite fast.
Yeah.
I don't know exactly.
Minutes, right?
I think so. Yeah, it should be fast, quite fast. But there's like if you want to start bridge, I think. Stargate, sorry. So this is like they also updated the whole like bridging from L1 and L2 and L2 to L1, and then it's quite fast. And there's other like Rhinify and all others that you can use.
Now, what about Stark? It's basically a gas token, just like in Ethereum,
Yeah.
and that's it, or does it have an additional?
So yeah, good question. So the Stark token is basically like will act as So you'll be able to use it as a gas token. I think at one point, so currently as a gas fee, Ethereum and Starknet is supported on L2, but at one point it'll be only Stark token. And it does have like other capabilities for decentralization. You can use it as a voting mechanism, so you can have your Stark to able to vote on different proposals. You can also delegate the Stark tokens. Yeah. Okay. Then I do want to just finalize on a few things. So we've seen this code. Hopefully it was not that scary. But now the question is where to start. So there's a lot of places to start. And whenever you're coming into a new ecosystem, it might be confusing because there's a lot of places to go. So we do have this developer journey that we created. And then it consists of 6 modules. And I would like to define them like by levels. So the first 3 modules is level 1, and the last 3 modules is level 2. The first 3 modules is learn, where you basically start to hear about Starknet, you start hearing about Cairo, and here you have the opportunity to check Basecamp. So Basecamp, I'll get to that in a second, but it's kind of like a free 4 to 6 week course that you'll be able to learn about Starknet, Cairo, and you'll also get hands-on experience. I started myself with Basecamp cohort number 2. Now we're at 12. And that's how I kind of like got into Starknet. I've learned about Starknet. We've learned Cairo 0 was terrible. It was a very difficult language, but the whole process was very nice. I've learned quite a lot. And since then, I kind of like always wanted to give back to the community, and I got myself involved. And yeah, it's just an amazing journey. Then there's Starklings. Anyone with Rust background, it's Rustlings, similar to Rustling. It's kind of like an interactive way to learn how to code. Then there's Node Guardians, Scaffold, Stark, and webinars. Then there's the next stage is connect. So this is where you already learned something and you want to connect and make connection in the ecosystem, the community. So there's various ways to do this. There's Only Dust platform, which is kind of like allows you to connect with developers and also like other people. Ambassador program meetups such as this, or even like Starknet meetups or conferences. Anytime you go to like an ETHCluj conference or DEF CON conference, make sure to check Starknet. We always have some kind of like a big conference happening there, and it's super nice. It's quite fun. I know like last time in the DEF CON we did have so the gaming folks are a bit crazy, and they had like actually like a boxing ring as their main conference, and they were like just doing a kind of like a podcast here on a boxing ring, and it was like very thematic, so it was quite fun. Then there's the build phase where you learn all of this tools and skills and also connections, and you take, like you can be a solo developer or you have a team, and then you can participate in hackathons, hacker houses, and also like ideation program. We all have this planned for you. It all starts with Basecamp, and then from there is just going with the flow. This is where you level up. So you level up from level 1 and you go to level 2. In level 2, we have the Kickstart, where you receive support from the foundation and from Starknet. There's seed grants and wrapper programs. I'll talk to that in a second, but basically you receive a certain amount of Stark tokens in grant, and you'll be able to develop your project business on Starknet. Then iterate, you can go through an accelerator program to help you even build faster and build your business faster, and you also get VC relations. And finally, the last module is grow, where you basically reach the maturity of the project, of the business, but also you get better support there. This is like the journey that we have, and I'll start inviting you with Starknet Basecamp. So again, this one is a 4-week program, bootcamp with a bonus session. So in the first 4 sessions, you have fundamentals, smart contracts, testing, and front end. And then the bonus session is build games with Dojo. So if you like building games, feel free to check that out. There's a link there. I can share the presentations later. And again, it's it's also the way I started. It's quite a good program, and it's quite fun.
When is the next?
Yeah.
Camp, when does it start?
April. So it starts April the 5th, maybe. I think so. Something like that. Yeah. So, and I think the time is quite good. Like, it's European focused time because there's like some big events. So for example, for ETH Denver, we were focusing more on the US region. And it was like quite late. But now like these ones are, I think, around like 5 to 6 p.m. or something like that. So it fits really good. Then you have like test your skills. So you already learned something. It's time to like show off. You have Starklinks, which is kind of like the interactive tutorial. Node Guardian is quite fun because it's like it's a very like gamified platform, and you have like a character that you can solve like CTFs, like you solve the various like small challenges, and if you solve them, you unlock items, right? And then these items you can equip your character with it, and then you can just show off to your friends, or I don't know if you can put it in a CV. It's gonna be quite fun. And there's like Exorcism, that's kind of like an open source platform. You can also solve exercises there. So there's a bunch of ways to do. And then time for building, it's as I mentioned, the seed grants. It's a program designed to offer grants up to $25,000 in Stark tokens. And basically, we are trying to support teams to build Starknet and develop their business ideas. Other platforms that I do invite you is OnlyDust. So OnlyDust is quite an amazing community overall. It's an open source community. There's open source believers. And basically, you're able to work on like state-of-the-art projects. And the nice thing about it is that you're able to develop your skills, you're able to connect with people, but also you're rewarded for your contribution. So if there's something that's interesting for you, you can explore OnlyDust. And that's it. I think that's my presentation. Feel free to scan the QR code if you want to. You'll have access to the presentation. And if there are any questions that I can help you answer, I'm happy to help.
When's the next hackathon? So you said you organized a hackathon recently.
Yes.
How are those? How do you organize it? What's different? What's the experience in there?
Right. So
When's the next?
So the next one is going to be in May. So usually how we have is like whenever you see this funnel, we always have like these pipelines. So we start with the Basecamp, then from Basecamp you have the hackathon, and then we have a hacker house. So once you start a Basecamp, there's like cool things that you can do. Like you can start learning, you go to a hackathon, you test everything, you build a POC, and then with that POC, proof of concept, you can go further to the hacker house. Hacker houses are nice because everything is sponsored, like the staying, the venue, the food, everything. You just have to show up with your team and develop the project. So it's quite nice.
And it's usually, you mentioned it before, so it's usually around venues of conferences.
Yeah.
So it's organized more like a side event or side event.
Yeah. Yeah, it's usually
big conferences, big Ethereum conferences.
Correct. It's usually like we tend to make it before those happening because I know like people are focused on the conferences, and then like they go to the conferences like ETHCluj or DEF CON. It's usually like it starts with 5 days before, and then it ends with 1 day before the main event. But usually like we have like now we have at ETH Denver one, we're gonna have at ETHCluj, or sorry, Cannes, not ETHCluj, but ETHCluj Cannes, and then Dev Connect, I heard it's gonna be in Buenos Aires. Yeah, this is like alpha. I don't know if it's alpha. Anyway, but yeah, usually we'll have like around these main events, and yeah, it's quite fun. You can participate with the Hacker House, and then you can join the conference later. The nice thing about the Hacker House, you also get access to like at the demo night. So you present in front of the public, like the top projects present in front of the public, and you have VCs, judges there, and then it's quite nice opportunity. Hackathon itself, they're quite like Starknet focused. And the last hackathon that we did in January. We had about 800 registrations with like 110 submissions in total, project submissions. And then it had like 5 different tracks. So we had DeFi, AI agents, Telegram, gaming, and community. And then, for example, if you're interested in particular track, you can develop, but also you could apply for multiple tracks. So, for example, you can develop like a Telegram DeFi app, right? That's also possible. They're fun experience. I think the one that we organized prior to that was quite successful, and the next one will be in May. So it's kind of like takes part of this bigger picture to funnel people, like give the journey for through the Starknet ecosystem. Any other questions?
What do you think it's missing on the EVM side? Because I think Arbitrum has like 20x the amount of Starknet.
Oh.
What is the foundation doing to this?
Good question. I think consumer apps. So we need, one or two big consumer apps. Like, so first of all, it's people are scared of like switching from something that's familiar, right? It's like from EVM to Starknet, because it's like there's a new technology, a new programming language. So definitely like there's some challenges. I think we have the network performance. We're trying Starknet Foundation, Starkware as well. We're actively trying to onboard companies and projects, and then like consumer apps. And I think what we're looking for is like the next one or two big consumer apps that will change everything. So it's like if you have the right thing, everything will snowball.
But there's no DeFi. What do you have in terms of DeFi?
Yeah, there's a bunch of them. I don't know, like if it's here. Yeah, so there's like you have like well, these are the centralized exchanges, the DeFi protocols. My name is zkland is there, but yeah, DEXs. So Avenue, like I don't want to pick favorites, but one of my favorites is Avenue and ETHCluj. These are like good DEXs. ETHCluj, they also like just released like I don't know if I can find it, privacy rules. So they just released this thing. I think is this one, is it?
Kubo is also have one.
Yeah, so ETHCluj, like the founder of Kubo is ex Uniswap, and then they decided to create something better, and then ETHCluj, and they recently just released these like privacy pools, and just leverage circuits with Starknet and Growth 16. Yeah, it's a bunch of nice things and innovation, and yeah, you can explore like the whole ecosystem, but there's a bunch of other DEXs as well.
And I guess all the concepts that are in DeFi are Ethereum for.
Yeah, even better, because you can create a lot of different things as well.
For example, lending or like launch pads.
Yeah. So Vezu, you can use Vezu as well for lending and borrowing. There's others as well. Cool. Any other questions? Yeah. Interoperability between rollups. There are some challenges, yes. But yeah, it's difficult to it's not straightforward. So definitely there's challenges between other rollups, especially being non-EVM completely. Like I think if you know, like there's the four types. Type 1, it's like full equivalent. Type 2, you have some equivalency. Type 3, and then we're type 4. Like we're not like, we're far away. But it's a big bet that we took, mainly because we try to focus on the technology on the scaling side. We came a long way. Like for example, like the community in 2020, there weren't so many people, but now like in terms of developers and community, it's growing. And yeah, it's challenging. There are some hiccups here and there, but they're solvable. And there's a lot of cool things that you can do with Starknet as well. You can have like Circum on Starknet, and like use Circum for proof generation of privacy. You can have Noir as well. So there's a cool library called Garaga that they do all of this interesting innovations, and then basically enables you to do like growth 16s, and then you can also use Noir and a bunch of other things. Yeah. Okay. Well, thank you again for inviting me here and listening to me, and thank you very much. It's a fun language. Like initially, like the whole transition from Cairo 0 was like this Pythonic thing, and you also had to take care of